Hello guys, welcome to AI Sciences. I am Sajjad Mustafa, your instructor for today, and today we are going to learn how to build a house price predictor. We will be doing some regression, we will be using some regression techniques for this purpose, and here is the agenda. First of all, we will start our project by loading this some data. Then we will explore some data, we will use some data visualization techniques. Then we will train our model, and finally we will be making some predictions. So guys, if you are new to this channel, we are AI Sciences. We make courses and videos for those students who are interested in artificial intelligence. If you are a beginner in artificial intelligence or data science, you're more than welcome to our page, and in the description you can find link to our more courses. So here we go. First of all, first thing first, we will import some libraries. We are importing pandas, we are importing matplotlib and SNS, which is cbonds. So let's run this cell, and here we will say data equals to pd is pandas dot read csv. Okay, and here we will say what is the name of our csv file, which is kc underscore house data. Now this file will also be provided to you. You can find the link for the course data in description. So here we have loaded the data, and let's see how our data looks like. So let's print head of our data, which means first 5 rows. And here you can see that our data has some ID, date, price of the house, bedrooms, bathrooms, and so on. A lot of features over here. By the way, we are not going to do any feature pre-processing over here. You can find my videos on data pre-processing in my channel. I will post the link of those data pre-processing videos in description as well, so you can pre-process this data by yourself. I am assuming that this data is already pre-processed. So let's explore this data a little bit more, and let's say data describe, and let's find out the summary of the data. So let's pick one, any of the feature. Let's say floors. So we have total count of floors is 21,613. Mean is this, standard deviation is this, minimum number of floors is 1, and maximum number of floors is 3.5. So this is sort of a summary of the data. And we also have some condition and view, and area in square foot, and basement and stuff like that. Okay, so now let's do some data visualization, which is an integral part of any data science project. So let's say data, and we want to visualize the data with respect to bedrooms. So I'll say bedrooms dot value underscore counts. Counts, and then we'll say plot comes from matplotlib, and we'll say kind of I mean type of the graph should be bar. So there should be a bar graph on bedrooms, and let's say SNS dot spine. Okay, so let's run it. And okay, so we are having some sort of error. Oh, so we have to we have done some typo over here. So this is value counts, and here we have done something wrong like this. Yeah, so yeah, you can see that. So we have most of the data that has 3 bedrooms. So roughly 10,000 records have 3 bedrooms, and 4 bedrooms. Record with 4 bedrooms have roughly I think 7,000, and so on. So maximum number of bedrooms that we have is, it looks like 7, right? And minimum number of bedrooms we have is 1, because houses with 0 bedroom is almost 0, actually really 0. Okay, so this is sort of a summary with respect to bedrooms, and you can plot more summaries according to your need. Let me plot one more summary for you guys. So let's say PLT. Now let's plot a scatter plot. Scatter, and here we will say data dot price. We want to compare the price of data, and with respect to what? We want to compare the price of data with respect with respect to square foot. So fsqft underscore living, right? So again, SNS dot. So let's run it, and here you can see that here on x-axis we have the prices of houses, and here on y-axis we have the area of house in square foots. And one more thing, you might be wondering that okay, house of price is $1 or $2 or something. No, we have 1 into 10 raised to power 6, so it is roughly 100,000, right? So here you can see that this is how we can plot a scatter plot uh, for to compare the price of house and with respect to the area of house. Now yeah, let's draw another plot, just a last one. So okay, so PLT, again a scatter plot. We will do we will try to do a scatter plot. We will try to plot a scatter plot, not do a scatter plot. So we will say data dot bedrooms, and the other thing will be data dot, again, price, right? And here again we will say plt dot show, right? And here you can see that. So here is the price of here's the price of data, and here is on x-axis we have the number of bedrooms. So if let's say number of bed, you can see that the if number of bedrooms are increasing, we can also see a rise in price as well. So this is sort of a summary of how can we visualize the data. Now let's move on towards train, test, split, or model training and stuff like that. So let's say train equals to data dot drop. So we want to drop two columns. Which two columns do we want to drop? ID, because ID is sort of useless thing, and then price, because price is also useless, right? No, I'm kidding. Price is not useless. This is our label, so we don't want to include price in the training data, right? And one more thing, yeah, I've done something wrong. Not drop. Here I should do something like this. Here I'll say x is equals to 1, yeah, so that it will drop from the columns, not from the rows. And then let's say train dot head. Let's see how our training data looks like. Here you can see that it doesn't has any ID now, and it doesn't has any price now. Okay, so the next thing is we are going to import from sklearn. We're going to import what? A linear model, yeah, and from a linear model get us linear regression. Yeah, exactly, this is what I need, buddy. Right, so here what we will do is we'll say, let's say my regression model is, let me instantiate this object, and yeah, so my regression model is linear regression, and then my labels are data, and here we will say what is our label? Our label is price, right? And then we also want to convert the dates, convert date, because format of date is not compatible right now. So what we want to do is we'll say 1 if values equal to 2014, else 0. We are sort of doing one hot encoding, not exactly but sort of. For values in data dot date, and then here we'll say data, replace the date column with converted dates. Awesome. And then finally what we want to do is we want to we want to drop some data from our data column, and let's say data dot drop, and here we'll say drop the ID and also the price. Also, it please do it for axis 1, which is the column axis. Oh, by the way, we have already done that, but there's no harm in doing this again, so let's do that. Oh, so it says that con dates. Okay, it is date, not dates. Awesome. Now what we want to do is we want to import train test split, and it will be available in sklearn library, sorry, sklearn. So from sklearn dot model selection, we want to import train test split, right? And then here we will divide our data into training and testing data. So we'll say x train comma x test comma y train comma y test, right? And from train test split we will get it in just one line of code. So feed training data to it and then tell the test size. In our case, test size would be 0.1. In other words, our data will be splitted in a way that only 10% of data will be considered as test data, and remaining 90% of data will be considered as the training data. And random state equals to, let's say, 2. Run it. Oh, so we have got an error over here. It says that not enough values to unpack expected for got 2. Okay, so let's see what wrong have we done. Oh, we haven't passed labels to it, right? Now let's run it. It says invalid syntax. Yeah, it's quite right because we have missed a comma as well. Okay, it's fine now. Awesome. So now we are good to go, and we are going to fit our regression model. reg.fit. What is reg? Reg is our linear regression model, right? So reg.fit, and here we'll say x train and y train, right? Let's run it. Oh, it's quite fast. Now let's check out what is the accuracy of this model. So regression dot score, and here we will pass some x test and what y test. It's labels as well, right? So it will compare these two. It will compare these two things. I mean, it will use features and it will predict its labels, and then it will convert. The score function will actually compare the predictions of x test with this y test, and then it will return some score. And in our case, our score is 0.73, which means our accuracy is 73%, which is sort of good but not good enough. So something that we can see is our simple linear regression model is not good enough in our case. So what can we do? What can we do is we can use some other regression model in order to achieve our goal. So you can play around with it. You can use some of other regression techniques as well. So let's use let's use gradient boosting regressor. Now, what is gradient boosting regressor? Let me tell you in a while. So first of all, let's import gradient boosting regressor from sklearn. So it's an ensemble learning method. So we'll say ensemble And here we will say, let's say gradient boosting regressor, let's call it GBR. Okay, and from ensemble dot gradient boosting regressor. Okay, so gradient boosting regressor is it's very much like random forest. We can make another video in order to do a depth and technical analysis of gradient boosting regressor. This video is mostly related to the implementation of GBR. So it is mostly it is roughly like random forest, but in GBR we use gradient techniques in order to achieve our goal. Rather than in random forest, we usually use the voting mechanism. So here we will say n estimators. Actually, let me run this thing as first. Oh, so it says that cannot import name from ensemble. I think I've done something wrong with the spelling. Yeah, ensemble. Yeah, now it's fine. Okay, now here I've also done wrong. Okay, so here I'll say n estimators equals to 200. So number of the estimators equals to 200. You can say that number of initial trees will be equals to 200, and then we will say max underscore depth will be equal to 10, and then we will say minimum sample split would be equals to 2, and one more thing, we will say learning rate should be equal to 0.1. This is another hyperparameter, you can play around with it, and your loss function would be equal to ls. Great, let's run it. Great, we don't have any error over here. So I'll say gradient boosting regressor, okay, sorry, gradient boosting regressor equals to, not equals to, but we want to fit it, dot fit, and here we will say x train, and also we want to put what, sorry, we want to put x test because we want to, oh, I'm vanished. So we are going to fit the data, we are not going to evaluate it, so we will pass the training data to it. So x train and also y train, we will pass these two things to in order to fit the data. So let's run it. It will take some time in order to complete its execution. Meanwhile, let's discuss about gradient boosting regressor. So it is very much, as I told you, it is very much like random forest. In random forest you have multiple trees, and then you find your final result by the voting mechanism. In this gradient boosting techniques, you find the result of one tree and then use this result as in the gradient of next tree, so that you know, okay, I've done this thing wrong, I have to move in that direction. So gradient tells you the direction, and then you move in the opposite direction of the gradient. So it actually boosts the input of next tree. So in this example we have roughly 200 trees, and this is the depth of each tree. So each tree can go up to maximum the depth of 10, right? And learning rate is 0.1, and loss function is ls, and this is the minimum sample split, which is right now it is 2. And here we go, it has run, and now let's check the score. Let's see if it is good or not. Let's see. Okay, so here what we will pass, we will pass x test because we are going to evaluate it, and then y test, sorry, y underscore test. Let's run it. Awesome, you can see that 0.91, which means 90, our accuracy is 91%. You can further play around with these hyperparameters, and you can even I think you can easily achieve an accuracy of roughly 95% on test data. That is awesome. Let's do some predictions. Y underscore predict. Okay, and here we will say gradient boosting regressor, please predict, give me some predictions on x test. Okay, and then let me show these predictions. Right here you can see that it has done a lot of predictions for us. So let's do it for just one value, right? Oh, so it says, yeah, because this X test is basically, it's basically a table. It's basically a pandas data set, so you cannot access any row like this. So let's access this row. Let's see if we can access it like this or not. What do you think? Okay, again key error, it says. So I think it has a function like dot index, x dot, yeah, and I think we can pass the index over here. Still no, it says no, I'm not going to let. Oh, so I was doing a basic mistake. Let's make use um, of slicing, and let's say I want to slice from 0 to 1, which means only one index, and here you can see that it has predicted the result. So let's see what is 0 colon 1. Here you can see that our data set, our data point is this. So let's say we have a data, we have a house with 4 bedrooms and 2.25 bathrooms, and living area is 2410 square foot, and so on. You know, everything is available. Condition is 5, grade is 7, and everything is available. Latitude, longitude, its location, and its zip code. So our model says that its price is roughly 703,361. Let's do it for for 2 data points, and here let's see another data point. So here you can see that for the second data point it says that its price is 128, no, I think it's roughly around 12 million. And here's the data point. It has 3 bedrooms, and you know, everything is available. Um, its area is slightly more than the other one. So here is, this is our goal that we have done over here. We wanted to predict the house prices, and we have done initially by using linear regression, and then we felt that our score is not high enough. So we have also done it by using another regression technique that is very famous regression technique. It's called gradient boosting regressor. We will make another video in which we will deeply explain what is gradient boosting regressor. Thank you for now.